Hi everyone, welcome back. Today we'll create a liquid simulation in Blender using my Among Us character as the effector. I'll guide you from the first click to the final bake so you can follow every step. I begin by adding a cube with Shift-A Arrow Mesh Arrow Cube. This cube will be the source of the liquid, or flow. I scale it down and move it above object. With it selected, press F3, type Quick Liquid, and hit Enter. Blender converts the cube into the liquid source flow and automatically creates a new domain object that surrounds the scene. As you can see, the smaller object inside is the source, and the larger surrounding box defines the borders of the flow animation. In simple terms, the domain acts as the limiter for a faster bake and for calculating the liquid animation. By pressing Tab, you can adjust the domain to cover the ground and objects you want to be interacted with the liquid. I lower the base to have the surface and object, and I will increase the base to not have motion limiter for liquid near the object. When you switch to solid mode, you can clearly see the domain faces. To view the liquid's main shape and the objects inside the domain, move the playhead to frame 1 in the dope sheet. When you click on the box at frame 1, the fluid properties will appear. These settings were created by the Quick Liquid option. If you prefer to set things up manually, you also have Smoke, Fire plus Smoke, and Fire Liquid options. By default, the liquid flow behavior is set to Geometry, which converts the object's volume to liquid. We'll change and test other options later in this video, but for now, let's press Tab to see the liquid simulation. By default, the liquid doesn't have a satisfying quality, as you can see. To check why, select the flow object and press the wireframe button, or hold Z and switch to wireframe with the mouse. Now you can see the particles that affect the liquid's density. These small blue dots represent the resolution of the liquid, and by increasing the resolution in the domain settings later, we'll achieve better quality. We've looked at the flow section, and for now, let's go to frame 0 or select the liquid inside the boundary box to enter the domain section. In the domain section, which is also adjusted automatically by Quick Liquid, we have several useful properties. In Settings, there is Resolution Divisions. This number determines the density of the liquid's particles based on the longest side of the domain. In other words, increasing it raises the quality of the liquid. Let's set the resolution to 64 and hit play. This is a real-time simulation bake, and you may experience lag and delays when generating frames, especially if you add effectors or increase the resolution. As you can see, the simulation is limited to the domain borders, but right now it passes through objects and even the base. In the liquid section, increasing the FLIP ratio preserves more particle velocity, which makes the liquid look more energetic, splashy, and lively. By default, it's set to 0.97, which is a good general value. I've set it to 0.5 because I don't want the water to be too splashy when it hits my character. Finally, check that Mesh is enabled. In Blender 5.0, it's enabled by default, so you should be good to go. In the cache section, you can set the save location of your simulation. This cache is different for each type of simulation, but make sure you have enough disk space. For example, my final simulation took up about 2 GB just for the cache. Below that, you have the simulation range, which is different from the animation range in the dope sheet. Basically, this defines only the start and end frames of the simulation bake. For instance, your animation length might be 360 frames, but you could set the simulation to run for only part of it, such as the first 120 frames. We'll test this later, so don't worry about it for now. Now let's test baking the simulation. I'll increase the resolution to 150. In some situations, you could also use more than 2 samples, but keep in mind it will take much longer to simulate each frame. That's why I'll keep it at 2. To ensure smooth motion without frame issues, you should bake the simulation once. Switch the type to All, check Resumable, and then click Bake All. Now we just have to wait while all the frames bake one by one. It might take some time. In the meantime, don't forget to subscribe if you enjoy this type of content, and leave a like if you've enjoyed it so far. I've checked the processing temps, and it looks like this iteration of the simulation is mostly based on CPU utilization. Press space on the keyboard to start the simulation. Now you can see the liquid quality is much better, and there are no frames lost when fast-forwarding through the timeline. However, you can also see that we haven't added any effectors yet, so the liquid still passes through the object and the base. Now let's add an effector to the character. While selecting the object, go to Physics Properties and add a fluid modifier. In the fluid settings, change the type to effector, and as you can see, it creates a simple collision based on the object's mesh. In some cases, depending on the normal face size and the liquid resolution segmentation, it may not be necessary, but you can also add a rigid body. Set the collision shape to mesh and increase the surface response friction to 1, just in case. Also, don't forget to set the rigid body type to passive at the top toolbar. I did the same for the base under the character as well. To see the effectors interacting with the liquid, you must rebake the entire process again. For rebaking, notice that all settings are grayed out and locked during the bake process. To make changes, you must click the Free All button to unlock and readjust the settings. As you can see, you'll need to bake again to calculate the effector settings. And remember, if you move any objects that affect the bake process, you must rebake the entire simulation from the beginning, even for small geometry edits. Now let's make an inflow liquid animation test, as we mentioned earlier. This method will stop the liquid flow at a certain frame. First, select the flow box and switch the flow behavior from geometry to inflow. This makes the box act as a source of liquid that flows continuously until the end of the simulation length. To limit the flow without shortening the simulation length, it's recommended to add keyframes for the outflow. For example, keep it set to inflow until frame 120, then at frame 120 switch it to outflow and insert another keyframe. This way, the animation of liquid flow stops at frame 120, but the motion of the existing liquid continues for the entire animation length. For example, the water will keep moving across the surface until frame 360. I'll do some readjustments to get better results with lower quality settings. For example, I lowered the resolution divisions to 36 and baked again to test it. Now we can see that the domain area could be a bit bigger, and you can also switch to render view even with a low resolution division. Also, take note of the material. Don't worry, Quick Liquid automatically assigns a basic water material by default. At this point, I just edit the surface and increase the scale of the objects to prepare for the final bake and the final animation rendering. I also adjust the simulation range in the cache to match the frame range of my animation. Since I added inflow-outflow keyframes, the amount of water is much more controllable. Finally, I set the resolution divisions to 150 and waited for the final bake with all the settings we covered, effectors and the inflow-outflow simulation. You can also check the time it took for the baking process. I also have a full camera settings tutorial, which you can check in the description as well. For lighting, I set up a 3-angle light and changed the base color to #B5E2FF. Next, I adjusted the cycles settings. I already have a full tutorial on cycles rendering, so I'll also link that in the description and add it to the end screen. Finally, for color management, I used ACES 2.0 to get more realistic results. If you're interested in my rendering and camera settings, you can pause the video here and copy these settings. If you enjoy Blender and 3D modeling content, make sure to subscribe to my channel. And if you like this video, don't forget to leave a like and comment what kind of Blender tutorials you'd like to see next. See you next time.